Hello everyone, welcome to Python and AI Engineering for .NET Developer series. Nowadays, AI is no longer a niche specialization. It has become one of the core engineering skills. This series is designed for the experienced developer who already know how to write code, how to ship software, but has not tried Python or AI territory yet. Every concept here we try to anchor around C# and .NET equivalent, so we don't have to learn from the beginning or learn from the scratch. We just bridge the gap between the already the product that's the C# and the .NET, and your target language as a Python. So you see the equivalence between two different programming languages, so it will be easy to switch over. So let's start with a clean environment, right? So we have our operating system which is on the global space, and we start to learn AI. The first thing we always do is to install the Python. So we use various commands. For example, in Mac I will use the brew to install Python. So what it does, it installs Python in a global operating system space, right? So now whenever you want to develop any application, and that application, let's say, has a dependency with certain packages. For example, let's say OpenAI version 2.8, we run the command pip install OpenAI. So you need to remember the command and why this command we should not use in the global space, right? So for example, when we do the pip install OpenAI, it installs the OpenAI packages in the global Python packages. Now we compile the application runs fine, and we are able to see the responses. So after a few days we started a new application, and now OpenAI version 1.12 is available. So when we do pip install OpenAI, now it install a new packages of OpenAI which is version 1.12. Now what will happen, right? So when a new version of a package is installed in the global space, the old application A, which actually was depending on a previous version of application, it will show conflict, so it will crash the application A, right? So this is one of the most common reason when a new developer comes to Python, start to install packages and start to write various program, they will face the major difficulty, and they most of the time they just quit even before they start writing the actual application code. So now coming back from a .NET environment where you see everything is very streamlined, right? So let's understand how .NET ecosystem works, and then we talk about how do we do the similar things in the Python setup, so our environment would be clutter free and clean. So now let's start understanding of a .NET framework that we all know as a .NET developer, right? Let's think of, we have the operating system. There are two different .NET framework is installed, .NET Core 8 and .NET Core 10, and we have created a new .NET project, right? So whenever we create a new .NET project and we open the CS pros file, we see there is a target framework, right, which will tell us whenever this particular application will get compiled, against which .NET framework the application will run, right? Similarly, we'll have all the dependent libraries of that particular .NET application defined as a package references, right? Similarly, when we see there are other files are there, we have the global.json file, which purpose is to specify which is the compiler version this application would be compiled against. So that means once you define a SDK version in global.json, it ensures every person in your team compile the source code against the exact same version of the SDK, so the output will be exactly same. Similarly, whenever we do a .NET restore on this particular project, it creates a packages.log.json file. So this file contains all the dependence packages of the application. So now again, similarly, we have the application source code, right, program.cs. Now what happens once you all setup is there, we want to do a .NET build, right? Once you do a .NET build, it compiles all the application and move all the libraries, dependent library, framework library, application compile, source code, all the content, it will move to a bin folder. Okay, so how to look like, we have our application A, which has a bin folder, which have the runtime library, which have the dependent libraries, which will have the compile source code and environment configuration file, which are specific for that application, right? So let's think we have a different application, right? This application can have different runtimes, different dependent library, and different configuration in the source code, right? Now whenever we compile all those things in a .NET application, it all get compiled and housed within the bin folder. So when we run application, we run from within the bin folder, which we call, let's say, your runtime environment, right? So then it ensures each application is independent. So even if there is a different packages, versions are there, different runtimes are there, so it will not pollute each other. So now let's start by learning how do we set up similar environment for Python. Okay, let's start with a empty folder and a console. I'm using VS Code for development, but you can use any text editor and any console. So first thing what we have to do is to install Python version manager called pyenv. So since I'm on Mac, I will use brew to install pyenv. So if you are on the Linux or you are in Windows, there are different commands available. For Windows, there is no pyenv, but there is a Windows wrapper on the pyenv called pyenv-win. You can install that. So once we already installed, for example, in my machine, I have already installed pyenv. So I can see either I can reinstall or I can continue. So once pyenv or Python environment version manager is already installed your system, so next step would be to check what are the Python versions available already in a system. So we used Python 3 hyphen hyphen version. So sometime you can also use the Python instead of Python 3, but typically the latest version of the MacBook and all, they support Python 3 instead of Python. But as I discussed before, right? So Mac, let's say, comes with a Python version which is part of its operating system, and we don't want to either pollute that OS version, or we don't want the OS version impact the application running, right? So what we'll use Python environment and install a .NET, install a Python version which is specific for application. For example, let's say I want to install 3.11.5. Okay, so in my case, I already have the Python 3.115 installed. So you can install any other version or you can continue. For example, let's say for our discussion, I'll use 3.11.9. So what it will do, it will download the respective Python libraries and it will install within this Python environment manager. That's a pyenv, right? So it ensures now whatever the version of the Python installed within this pyenv, then the Python version manager can control those Python environments. So now the Python versions are installed. So in my local, within the Python environment, in Python version manager, I have two Python versions. One is 3.11.5 and 3.11.9. So now let's say we start our development and we want to develop application, let's say, which targets version 3.11.5. For that, we have to first write the command pyenv, then local, and version of Python that I want my local application should run against. Now here we have to ensure we run it against the local, not against the global, so that this particular Python version would be applicable to my local environment only. So when you run this particular command, it will create a .python version file, and there we see the Python version would be specified. Now if I go back and write the Python and hyphen version, now we see it's taking care of my local version of the Python which is targeted based on my Python environment specified. Now till now we have just specified Python environment to consider 3.11.5, but now we have to create an environment or a runtime environment for application to run. For that we need to use Python, then module. There is a virtual environment venv module, and we can give any folder name. For example, I'll give .venv, and what it does, actually, okay, sometime you get this error, so not to worry, we can just delete it and run this particular command again, then it will create the version file. Right, so now you see the version, we run the command, it created a version file. So let me clear it. Okay, so now if we expand this .venv, we see there is a bin folder like our .NET bin folder, and here we have certain Python versions already there. If you see the 3.11 version, then we have your library folder. Here Python default installation comes with certain Python packages, and whenever we go ahead and install the new Python packages, those things also would be installed within this particular folder. So we have to activate the version, so all our development would be targeted to the respective version. To do that one, I need to write source space, we need to go to the virtual environment folder, bin folder, and there is a activate. So once I activated, we see our command runs from within the virtual environment. So if you are writing in the Windows machine, then there is no source, we just have to go to venv, then there is a script folder and activate, or activate PowerShell script. We can run either of these, then the same virtual environment would be active. So once our virtual environment is active, whenever I write any command within this particular environment, then it will target and the runtime would be with respect to the respective environment only. So this is the very basic setup we need to do in every developer machine whenever we start writing a code. But this is not all, right? So let's say if we draw an analogy between my .NET application, it's like creating a .cs pros file. We have not created any configuration file, we have not created any packages, dependencies, right? So now it's just creating a plain simple project file considering the target framework, runtime version, and how do you ensure when you compile the file and run the file, it's run from a local bin and bin folder or local environment, right? So now the next step would be in a traditional any application, when you start writing, we need to add the dependencies. So how do we manage the package dependency within a Python application? Again, all the commands subsequently we will write that would be targeted within this venv folder. That's very crucial. If we just run without activating the venv folder, all the installation will again go back to your global scope, and then it will start polluting your global environment, right? So to start writing any packages or any dependencies, Python provides a tool called pip. Okay, so we'll use the pip command, and then we'll have install, which will install, and the pip stands for, it's a recursive acronym which stands for actually pip install packages. We use pip command to install any packages. So there is one packages called pip tools, which actually used to manage your dependencies better, right? So once I install pip tools, if I go back and see my environment, we see there are two new commands has been installed. One is called pip compile and one is called pip sync. So these two commands are crucial for us to create a dependencies and ensure all dependence packages or local environment is synced with all the dependencies. So to start, we need to create one file. Let's say I'll create the default name that Python follow is a requirements.in file. In the requirement.in file, we just have to go ahead and define the package versions that we need. For example, let's say we want to develop a AI application, right? So I need to have a dependency on OpenAI. So I'll not specify the exact version. So whenever we install this particular version, it will take the latest version available as of now, as of the time we compile it. Okay. So there will be few other packages. Let's say we'll go ahead and install .env. Again, I'll come back to what about this .env packages. But your requirements of in file is just very simple. You just define all the packages that we application depends on. So then we'll use pip compile command and pass the requirements.in file as an input. So what it does, it actually look into the requirements.in file, look into packages that are specified in requirements.in file, then it actually create a dependent packages.log file like your global.json, global.log.json file, right? Or the packages.log.json file. It creates a requirement.txt, right? Now requirement.txt file will contain the detailed packages that are dependent based on the hierarchy. For example, we have your OpenAI, right? And whenever we installed OpenAI, and there are other packages that OpenAI depends on. For example, we have the distro packages, or we have these, let's say, HTTPS package which depends on OpenAI, and any IO package which depend on HTTPS. All those versions it will try to identify and install and create a requirements.txt file. So what I need to remember, requirement.txt file is kind of a log file which actually should be used whenever we want to set up our local environment. But whenever we want to add a new packages, we always should go to requirements.in file and specify the package. So this requirement in file should be human managed. So we as a developer, when we explicitly want to add something, we'll add it here and run the pip compile command, which actually create the requirements.out file or requirements.txt file. Okay, so now once the requirement.txt file is created, the next command we have to run is pip sync, and we need to pass the requirement.txt file. So once we run the pip sync command, what it does, it looks into your requirement.txt file, identify all the packages that are defined here, then it syncs your local environment, which is under the .venv folder, with the packages that defines. So it does three things. First of all, if a local environment does not have the package, it will install it. And if the local environment already have the same package version, then it will ignore it. But let's say we are doing some kind of experiment and we have manually installed packages directly within the virtual environment. If we sync, it will remove those packages which are installed manually within the virtual environment but not defined in the requirement.txt file. So now if I expand, let's say bin, we still have those many commands that was defined before, and alongside the .NET env command got added. Then if I go back to your library, all the packages that are defined or that are dependent on two packages we installed, one is OpenAI, one is called .env. So those things got installed. So now that's how we can specify the package dependencies within our application. Okay. So then the last thing for any environment setup in local or whenever we want to deploy, we should have an environment configuration file. It is something similar to like appsetting.json file where you define various key value pairs, and those things will be specific to your local environment or whatever the target environment is there. For that, Python creates or supports a file called .env, which is .environment. And, so within the .environment file, we can create key value pairs. For example, I'll say OpenAI key, and let me give some key, right? For any other configuration also, if you want to define, let's say my base URL, I just define something as my base URL. It's just like a key value pair. Okay. So now in our application, we should be able to read this key value pair, and it's something similar whenever we run a .NET application, the program.cs file. This actually reads all the configuration wrap setting JSON file from your files, from the environment configuration, from your parameter, and create a in-memory library or dictionary of all the key value pair, right? So let's start by creating a simple Python file, and all the Python file will have a extension.py, and there we want to read this particular environment. Now if you remember sometime before, we have defined one package dependency called .env. Now .env package is actually used to load this environment configuration file into Python application. So to run any .env file, okay, before we go there, let's see how do we run a very simple Python command, right? So we'll just say print, and then we write whatever text we want to put. And if you want to just run this particular file, we just have to define and come to, let's see, let me clear it. Then we'll write a command Python and specify our Python file name, which actually runs and writes or execute my script. Now let's extend it and see how to run the load the environment variable. So to load the environment variable, we have to import one package called OS. Then we have to load the .env load.env function from .env package. We'll learn about more how do you write this import command, but let's take with a pinch of salt like the other standard way we need to write any the other standard way how we need to load the environment variable. So once we load these three, or once we write these three lines, whenever I want to read any specific key, we can just use OS get environment OpenAI key, the name of the key, right? So it will give you the value and assign it to a variable. Now let's say whenever I want to write, I can just say whatever the key and whatever the URL, right? So now this is also, remember here is a simple string, but whenever you want to insert some variable within the string, like we have the string format in .NET or your $string, so here you specify f string, right? F means format string. So within the format string, we can have the curly braces and I can define the variable name. So now if I run my application, right? So now it ran the respective key values from your environment file, and using the load environment, it load the all the configuration into the application. Then using the OS get environment, we can read and use those variables wherever our application needs. Okay. I think that's actually conclude everything we need to do to set up a local environment. Okay. So now before we conclude the application, we'll do two steps. First of all, once we create a new .NET packages, right, and we'll check into Git repo. So what are the files we need to check into Git repo, and what are the files we need to ignore it. So let's let me start by initializing a local Git environment here. So once I set up a local Git environment, let's create a .gitignore. Okay, so in the gitignore file, like we never check in the bin folder, obj folder. Similarly, we'll never check in the .venv folder. Okay, something similarly, .env file. A .env file actually contains all of our keys that's being locally we are running, right? So this file also we usually don't check in. So what we do instead, we create a new file .env.example, and here we can define those same keys, for example OpenAI key and something. So which application will not read, but it will just be example whenever anyone take this particular source file and they want to run locally, they will need to rename the .env.example to .env and then give the actual configuration value, right? So once we do all those things, what will happen? Only our example or the application, only these many files would be check-in. So now let's think of a scenario, someone check-in, we take this particular version and I want to set up my local environment with the same application versions, packages, all those things. In the .NET environment, how do you do? We check out from a repository and then we just run the .NET restore, which actually reads all the configuration file and sets up a local environment which will be exactly similar to the any source environment, right? So let's try to simulate that particular behavior. So to simulate the behavior, let me delete that BENB file. So let me clear it. Okay. So what I'll do, so I'll try to this is to simulate. I have checked out the code from the repository. So first thing what we have to do, we have to look into .python version. Okay. So okay, before that, let me go back to my console. Okay, so we first see what the Python versions is installed, and we have to again anyway make sure the pyenv is installed. Then we need to use pyenv and install 3.11.5. So this is only if this particular Python version is not installed in the machine. If Python version is already installed, then we should skip this one, right? So the next command what we have to run is python hyphen module venv dot venv, which will actually make sure to create my local virtual environment folder with this particular environment as a target. Again, but if you see the package leave, there is no additional package, it's just a plain vanilla installation. Once we do, the next thing we have to do is always activate the virtual environment. So we should always remember, this is something we should never forget. Every command would be from the virtual environment. So once we're done, then we have to run pip install pip tools. Okay, so now to install the pip tools, we see the pip tools, pip commands are available. Then since the requirements.txt file is already checked into the repository, so we have to just run pip sync and requirement.txt file. So what it does, it actually installs all the dependencies what are there in your defined in the requirement.txt file and install it. Now after we do this pip sync, which is exactly similar to the .NET restore, our local environment is ready. So you can just go ahead and run the command. Okay, which actually read your configuration file and execute and so on. So this is how we can set up a clean Python local environment which is always repeatable, clutter free. The scope never goes beyond your application scope. Since it is a AI programming series, so let's wrap today's discussion with a small AI application where we'll use a console chat client, wherever we'll ask a question and we'll let use the OpenAI, which actually call the respective LLM model to get some response. So to use that one, so I've already specified the OpenAI key and the base URL in my configuration. So you can also specify something similar in your application. And let's say we start with day 1, and I'll create a file called, let's say, app.python file, and we'll again go through the same set of command, import OS, and then from .env load env. So till now it ensures all my key values are loaded. Okay, so now since we are using here OpenAI command to actually run any specific AI queries, so I'll also import the package OpenAI. If you remember, we have specified the OpenAI dependency as part of our requirement.in file. So I'll come back to OpenAI. So we'll start by creating a client, which is a OpenAI client, and then we can specify what is our base URL, what is the key. Okay. So then we can write a response, and response will make a call to chat completion API, and to chat completion API will pass the model, and we need to pass two messages, one as a system role message and one as a user role message. Okay, so once I get the response out, then we'll print the response content. So let's do some changes. So I'll target the model available to me, which is 4.1 mini. And instead of hard coding the message here, so we'll use a much interactive way. So I'll just say it actually input is just like our console dot read, where it will add this particular text, so show the particular text and have the cursor. Then whatever you write in the cursor and press enter, that particular value would be read. So here our question would be read. Then it will pass that as a user prompt, and system prompt I'll keep this very simple, as like a helpful assistant. Then I'll make a call to my OpenAI with the respective base URL and passing my key and targeting model. Okay, so now let's save this application, and then to run this particular application we have to write Python. We have to go to respective folder and the respective application. When I run, it will start asking for you, and it stops here, right? So where you can write, so how does .NET developer can learn. So now what it does, it actually read this particular query and construct this particular object, and then send that API to the respective base URL, get the response, and the response is the message content, and the message content is being written here. So this is a very simple application. How can we use the Python models, and how can we make a call to OpenAI to get answer to specific queries. And that's all everyone for today. So today we learn how to set up a clean AI development environment. So in the next session we'll learn about the Python modules, packages, and write some complex AI code. So stay tuned. Everything we covered today, including the scripts, the configuration, the extended documentation, is available right now on techwayfit.com. While you are there, check out our deep dives into various technical blogs like on enterprise security, design principle, or put your skill to the test with our develop focus quizzes. And if you're ready to master the intersection of the .NET and AI, subscribe to the channel, and I'll see you in the next video. Thank you.